Hello everyone. So for our topic for this video, we have Descartes' rule of signs. So we have our learning target for this video. I can use the Descartes' rule of signs to find the number of possible zeros of a polynomial function. So first, the number of positive zeros has something to do with the number of variations in signs of the given polynomial functions. So here, I just would like to emphasize, if you want to know the number of positive zeros or else negative zeros, you need to be familiar or particular first with what is variations in signs or variations of signs. So if the terms of a polynomial function p of x are written in decreasing order according to the powers of x, ignoring the missing term, each pair of successive coefficients with opposite signs is called a variations of signs. Or in other words, if we say variations of signs, that means difference in signs or variety in the sign. So let's have an example for this. So determine the number of variations of signs using the given polynomials. So first, we have this polynomial x cubed minus 2x squared minus 5x plus 6. Now, for us to identify the variations of signs here in our polynomial, so I'll just rewrite it first. X cubed minus 2x squared minus 5x plus 6. So for us to identify the variations in signs here, so let's consider the signs in each terms of the given polynomial. So in our first term, we have here positive. In our second term, we have negative. Third term, we have negative. And fourth term, we have positive. Now, if we're going to observe our signs, so from the first term, so let's have positive, it becomes negative. So is there a variation? Yes, so we do have variation already. We do have one variation. Next, from negative, it becomes negative. So does the sign vary? No, so it is not counted. There is no variation in this scenario. Next to that, we have negative becomes positive. So, do you think the sign varies? Yes, so here. So, our final answer for us to find out the variation of the given polynomial, we just simply count all the variations that we have. As you can see, we do have 1, 0, 1. So, we have 1 plus 1. All in all, our final answer will be, we do have 2 variations in signs. That's it. Okay, let's have another example. So we have here our polynomial 2x cubed plus 13x squared plus 17x minus 12. Now, so let us consider the signs that are used in the given polynomial. So we have here the first term, we have positive. Second term, we have positive. Third term, we have positive. And fourth term, we have negative. And observe the variations in the signs. So we have here positive to positive, there's no variation. Positive again to positive, there's no variation. And positive to negative, then we do have one variation. So all in all, our final answer in our given polynomial, we do have one variation only. Okay, so you can write one variation only, or completely you can write one variation in signs. Okay, so next example. So we have here x cubed minus x squared plus x minus 1. So we are going to check the signs used in the given polynomial and same example, the polynomial given is already arranged in decreasing order, so we can now proceed with checking the signs. So we have positive, negative, positive, negative. And now let's count the variation if there is. So positive becomes negative. So yes, there is a variation. Negative becomes positive, and yes, there is another variation. And positive becomes negative, so there is another variation. So all in all, how many variations do we have? We do have 3 variations. And that's it. So here, for me to be able to check if you were able to understand the concept about number of variations of signs, now let's check. I would like you to identify the number of variations of signs in each polynomial. Okay, so here we do have 2 variations. Next, we do have 4 variations. And lastly, we have 5 variations. And that's it. I hope you understand how to find the number of variations of signs in the given polynomial. Okay, so here's the Descartes rule of signs, wherein we are going to apply the concept about number of variations in signs. So for us to find out the number of positive zeros or positive roots in the given function, so we can apply this Descartes rule of signs. So here, so the number of positive real zeros or roots of p of x is equal to 0 is either equal to the number of variations in signs of p of x or is less than the number by a positive even integer. And for us to identify the number of negative real zeros or roots of p of x equals 0, so it is either equal again to the number of variations in signs of p of negative x or is less than the number by a positive even integer. So I guess you will be able to understand more if we're going to proceed with our example. Okay, so let's have here problem number 1. Determine the possible number of positive and negative real zeros. So here in our polynomial function, first of all, before we look for the possible number of positive and negative zeros, at the same time the imaginary or complex zeros, of course we need to be particular first with how many number of zeros are we supposed to have out of this given polynomial function. So as you can see here in our polynomial function, our highest exponent, or we can say the degree of this polynomial function, is 3 or third degree. So therefore, we are expecting 3 zeros out of this polynomial function. But out of those 3 zeros, how many are positive zeros, how many are negative zeros, or how many are imaginary zeros? So let's have here set of possibilities. So I'll just use table to organize all the data, all the possibilities that we can have. So first of all, let's find out the maximum number of positive zeros. So how can we identify or determine the maximum number of positive zeros that we can have? Okay, so we will apply here what we learned about the number of variations a while ago. So here, as you can see, our given is in the form of p of x already. Therefore, we can now start counting the variations in signs of the given polynomial function. But of course, first of all, let's check if it is arranged in decreasing order, and fortunately, it is already arranged in decreasing order. So it's time for us to count the variations in signs. So positive x cubed becomes positive 7x squared. So positive and positive, is there a variation? So there is no variation. Positive 7x squared, next to that is positive 14x. So both positive again. So is there a variation? None. And same goes with positive 14x and positive 8. There is no variation. So therefore, we can say that applying the Descartes rule of sign, so the maximum number of positive zeros is 0. So that means we don't have positive 0 here in our polynomial function if you are going to find the zeros of this function. Okay, so applying the Descartes rule of signs, so as stated a while ago, it's either equal to the number of variations or else less than by even integer, or in other words, just simply deduct by 2. That's another possibility. So as you can see, our maximum number of positive zeros is 0 already, and if we're going to deduct it by 2, so we will have negative 2, and it doesn't make sense. For example, you are asked, how many bags do you have? So can you say, I have negative 2 bags? So it doesn't make sense. That means, so instead of writing negative numbers there, counts of a particular positive 0, so just simply put a 0. Okay, so for negative zeros, for us to know the maximum number of negative zeros that we can have, so we are going to apply already the p of negative x as mentioned in our Descartes rule of sign. So for us to find the number of positive zeros, we will just simply rely in the given polynomial function. But for p of negative x, we really need to modify first the given polynomial function. So how? We are supposed to change all the x or the variable x in the given polynomial function. We change it into negative x, all of those x, so remember that. So 14 negative x plus, and just simply copy the constant. And we are not yet done. You need to simplify this. So we are supposed to simplify this. So let's have negative x raised to 3. So negative x times negative x times negative x. We will still arrive with negative x cubed. Okay, next. Negative x squared. So it will be positive x squared. So positive x squared multiplied with positive 7. So we will have positive 7 x squared. Next, positive 14 multiplied with negative x. So we will have negative 14x. And of course, simply copy the constant. And we're done. We were able to simplify the polynomial function already. And this is the time for us to count the variations in signs. As you can see, we have negative becomes positive. So there is a variation. Then positive becomes negative. So there is a variation again. And negative becomes positive. So there is a variation again. So all in all, how many variations do we have here in our p of negative x? 3. So therefore, the maximum number of negative zeros that we can have is 3. But aside from the maximum number, as per stated in our Descartes rule of signs, it's either equal or less than by an even integer, and that means you just simply deduct by 2. The even integer there mentioned, it refers to 2 only. So 3 minus 2, so another possibility. So we may have either 3 negative zeros or 1 negative zeros. So can we continue the process? 1, then we will deduct again by 2, and we will have negative 1. So it's negative, so it doesn't make sense. So you just end with 1. And so for imaginary zeros, we just simply do this, guys. So as you can see, our number of zeros, we are expecting 3 number of zeros out of the given polynomial function. So you just simply use your common sense for this. So if we do have 3 number of zeros here, So let's say our set of answer will be all the maximum data here. So 0 positive zeros and 3 negative zeros. So 0 plus 3, it is equal to 3. So it's 3 zeros already. Therefore, there will be no imaginary zeros if that's the case of our answer. But if our answers follows the set number 2, so if we don't have positive zeros but we do have one negative zero, therefore we can say that the remaining 2 zeros will be imaginary zeros. So that would be the possibilities of the answer that we can have. So if you're going to get the roots of the given polynomial function and it happens that you found 2 positive zeros and 1 negative zero, then that means you are wrong. So again, the tendency or the possibility of your answer, it would be 0, 3 or 0, 1. So that's the purpose of applying the Descartes rule of signs. Okay, so next problem. So same, determine the possible number of positive and negative zeros of the given polynomial function. And again, you need to identify first how many zeros can we have out of the given polynomial function. So it's 5 because the highest exponent there is 5, or the degree of the given polynomial function is 5 or 5. So let's have this table to organize our possibilities or sets of positive or number of positive zeros, negative zeros, and imaginary zeros. So first of all, so for us to find again the number of positive zeros, the maximum number of positive zeros that we may have, so you just simply count the variations of signs of the given p of x. As you can see, positive, then becomes negative, so there is a variation. Negative becomes positive, so there is a variation again. Positive becomes negative, so there is a variation again. Negative becomes positive, there is another variation. And positive becomes negative, there is variation. So all in all, how many variations do we have? 5. So we can say that the maximum number of positive zeros that we may have is 5. But as per stated in our Descartes rule of signs, it may be equal to the number of variations or less than by an even integer, or just simply deduct by 2. So 5 minus 2, it's 3. And we can continue the process by deducting again by 2. So 3 minus 2 will have 1. And that's it. So if you will ask me, Miss, can I continue to, can I deduct again 2 from 1? So 1 minus 2, we will have negative 1, and it doesn't make sense, right? So instead, we'll just stop there at 1. Next, of course, for negative zeros, to find the number of negative zeros, so of course, we'll just do the p of negative x. But instead of doing that, we can use our common sense here. As you can see, here, the maximum number of positive zeros is 5. So, of course, if our maximum number of positive zeros in our first set is 5, and the number of zeros we are expecting is 5, so therefore, how many negative zeros we will have? So, 0, right? So, because we do have 5 already for positive. So, since 0, then that means the rest of the possibility will be just 0. And for imaginary zeros, there is no need for us to count the variations of signs as well. So, just use our common sense. So, if we do have 5 zeros, positive zeros, and no negative zeros, so we will have 0 imaginary zeros because 5 plus 0 plus 0 will have 5. Our basis here is the total number of zeros that we can have out of the polynomial function. So it's 5. So it would always be equal to 5 if we're going to sum up all the rows there per set. So 3 plus 0, it's 3. So what would be the number of imaginary zeros so that we can come up with the total number, which is 5? So it's 2. And lastly, if we do have one positive 0 and none negative 0, so how many imaginary zeros are we going to expect? So 4. So that's it. As easy as that. Okay, so here for our problem number 3, you may pause the video for a while and answer this, and if you're done, you may resume watching to check your answer. So here's the answer for this problem. So we have here positive number of zeros. The maximum number of positive zeros would be 4. And then less than to that, minus 2, so we'll have 2, and less than to that, so we will have 0. And for negative zeros, of course, common sense again. So since the number of positive zeros, the maximum is 4 already, therefore, what would be the maximum negative zeros? The number of negative zeros, it will be 0. And follows with, of course, 0, 0. And for imaginary zeros, again, I just would like you to use your common sense only again. For imaginary zeros, you don't need to count the number of variations of signs. So 4 plus 0, it's 4 already, therefore for imaginary zeros, there's none. If we have the second set of the possibility of the number of the zeros, so 2 plus 0, it's 2, so we are expecting 2 imaginary zeros. And if the third set will be the answer, so no positive zeros, no negative 0 answer, so therefore all our zeros will be 4. So these are the 3 tendencies if we are going to find the zeros of the polynomial function. So again, if you want to find the number of zeros of the polynomial function, of this polynomial function, and you came up with 1 positive 0, 1 negative 0, and 2 imaginary 0, it doesn't correspond to what we have here in our applying the Descartes rule of signs. Therefore, it's wrong. There's something wrong with your answer. So, the possible answer would correspond to our result here in the table. So, one of the sets here given. Okay, so that's it for this video. I hope you learned about the application of Descartes rule of signs. Thank you so much for watching. Please don't forget to subscribe.